The next question is, an RCC short column with lateral ties of rectangular cross section 250 cross 300 is reinforced with 4 members of 16 mm diameter longitudinal bars. The grades of steel and concrete are Fe415 and M20 respectively. Neglect eccentricity effect. Considering limit state of collapse in compression, the axial load carrying capacity of column is. Now we have to neglect eccentricity effect, therefore the load capacity will be given by 0.45 FCK into AG plus 0.75 Fy. Since it is Fe415, we will use 0.75 minus 0.45 FCK into area of steel. So this is equal to 0.45 into M20. So 20 into gross area will be 250 cross 300 plus 0.75 Fy is 415 minus 0.45 into 20, and area of steel will be 4 members 16 mm diameter. So 4 into pi by 4 into 16 square. So it comes out to be 0.45 into 20 into 250 into 300 plus 0.75 into 415 minus 0.5 into 0.45 into 20 into pi into 16 square. So it comes out to be 918.08 kilonewton. So up to one decimal place, the answer will be 918.1. This will be our answer. The next question is, the ultimate BOD L0 of a wastewater sample is estimated as 87% of COD. The COD of this wastewater is 300 mg per liter. Considering first order BOD reaction rate constant K, use natural log equal to 0.23 per day and temperature coefficient theta 1.047. The BOD value after 3 days of incubation at 27 degrees Celsius for the wastewater will be. Now the ultimate BOD L0, it is given to us 87%, that is 0.87 times of COD, and COD is 300 mg per liter. So L0 comes out to be 261 mg per liter. Now we have to determine the BOD value after 3 days, but temperature is 27 degrees Celsius. Now the reaction rate given as 0.23 per day, it is applicable for 20 degrees Celsius. So to determine K at 27 degrees Celsius, we will use the relation K27 equal to K20 into theta to the power T minus 20. So this is equal to K20 is 0.23, theta is 1.047, temperature is 27 minus 20. So it comes out to be 0.23 into 1.047 to the power 7. So this is 0.317 per day. Now BOD after 3 days will be equal to L0 into 1 minus e to the power minus K27 into T. So this comes out to be L0 261, 1 minus e to the power K27 is 0.317 and time after 3 days. So this comes out to be 160.23 milligram per liter. So the correct answer would be up to one decimal place 160.2 value. The next question is, a solid circular beam with radius of 0.25 meter and length 2 meter is subjected to a twisting moment of 20 kN per meter about the z-axis. This is the z-axis at the free end, which is the only load acting as shown in figure. The stress component tau xy at point M in the cross section of the beam at a distance of 1 meter from the fixed end is. So this is total 2 meter. Point M is lying at the center point 1 meter from fixed end, and we have to determine the tau xy. Cross section is given to us. Now we must note that what tau xy implies. So tau xy implies that the shear stress is calculated on a plane which has normal in the direction of x, and we are determining the shear stress in y direction. So suppose, to understand this, suppose this is our plane. Now if shear stress is acting on this plane and we are denoting it as tau xy, then the normal to this plane should be x value, x direction, and if this we are calling as tau xy, then this direction should be y. So again, repeating, tau xy implies that shear stress is acting on a plane whose normal is in x direction, and the shear stress is acting in y direction. Now coming to this case, it is given to us cross section is in xy plane. It implies that we have to determine shear stress not at this cross section, because for this area the normal will be z direction. So if it would have been tau zy, then we can say that we have to determine the shear stress on this plane. But for our case, plane will be such that its normal is y. So here this is z axis, this is y axis, and this is x axis. So since this is x axis, our plane will be this, and we have to determine stress in y direction. So y axis will be this. So again drawing, this is our M point, this is x axis according to the given figure, and we have to, and this is z axis, so this will be y axis, and we have to determine shear stress tau xy. So this is the plane and shear stress in y direction. This will be our tau xy. Now we can say that at this plane shear stress will be 0. If would have been tau zy, if the question was asking us about tau zy, then the plane would be this value. This will be our plane, and for this case tau zy will be equal to 16t by pi d cube. So for our case, answer will be 0. The next question is, in a fillet weld the direct shear stress and bending tensile stress are 50 MPa and 150 MPa respectively. As per IS 800-2007, the equivalent stress in MPa up to 2 decimal place will be. Now we have to apply the direct relation. Since there are two different nature of stress, one is shear stress and other is tensile stress, IS code gives an interaction equation. The equivalent shear stress is given by under root of FA square plus 3Q square, where FA is the tensile stress and Q is the shear stress. So putting the values, tensile stress is 50, tensile stress is 150 and shear stress is 50. So it comes out to be 150 square 4 into 150 square plus 3 into 50 square. That is 173.2 MPa. So the correct answer would be 173.2. The next question is the percentage reduction in bearing capacity of a strip footing resting on sand under floating condition, that is water level at the base of footing, when compared to the situation where the water level is at a depth much greater than the width of footing is approximately. Now the setup is like this. This is our soil mass and the strip footing is resting on the sand. So this is our footing, and there are two conditions. In one condition there is flooding, so water level will be up to this depth, and the another situation is that water level is at very large depth. Now we know that for the general case the bearing capacity is given by CNC plus QNQ plus half gamma B N gamma. Now since it is given to us the soil is sand, so C will be 0, this term will get neglected, and also it is given to us that it is resting on the sand surface. So if it is resting on sand surface, Q will also be 0. So it will be simplified as half gamma B N gamma. Now there are two cases. For first case water level is up to top surface. So in this case QU will be equal to half, gamma will be gamma submerged B into N gamma. And in second case water level is at a much larger depth, so here QU will be equal to half, gamma will be only gamma saturated into B into N gamma. Gamma saturated, or we should write is at bulk density. It will not be gamma saturated but any value corresponding the saturation condition. So for this case we can say this by this will be equal to QU1 QU2, this divided by this we will get gamma submerged by gamma bulk. Now we can say approximately this value will be equal to 50%. So the correct answer would be C option. The next question is the deformation in concrete due to sustained loading is. So at the constant loading, if deformation occurs, then it is called as creep deformation. So it is a direct answer, that is A option. The next question is the speed density relation for a road section is shown in figure. The shape of the flow density relationship is. So speed versus density K, V versus K graph is given to us, and we have to determine the flow versus density. So flow, that is volume, so it is Q versus K graph we have to determine. Now we know that Q is equal to V into K. Since up to this case velocity is constant, so we can say Q will be directly proportional to K, and if Q is directly proportional to K, relation will be something like this, linear. And after that V is a linear function of K. So for second case, if V is a linear function of K, suppose mk plus C into K, then we will get a quadratic equation, that is mk square plus ck. So this is a parabolic variation. Hence for first part it will be linear and after that parabolic. So the correct answer would be initial linear and then parabolic, that is C option. The next question is a steel column ISHB 358 72.4 kg per meter is subjected to a factored axial compressive load of 2000 kN. The load is transferred to a concrete pedestal of grade M20 through a square base plate. Considering bearing capacity of bearing of concrete as 0.45 Fck, where Fc characteristic strength, using ultimate state method and neglecting the self-weight of base plate and steel column, the length of a side of the base plate to be provided is. So it is a direct question. We know that the area of base plate will be given by load acting on the plate divided by the bearing strength of the concrete. Now, therefore, we'll write area will be the load acting divided by the bearing strength, that is 0.45 Fck. So it implies that Pu is given to us, factored load is 2000 kilonewton. So 2000 into 10 to the power 3 Newton divided by 0.45, and Fck is 20 Newton per mm square. So area comes out to be 206 by 0.5 divided by 20. So it is 222.222 into 10 to the power 6, so 10 to the power 3 mm square. And since it is a square base plate, so length of each side will be equal to under root of area. So it comes out to be under root of this value, that is 471.404 mm, that is 47.14 centimeter. So the correct answer would be D option. The next question is, for routing of flood in a given channel using Muskingum method, two of the routing coefficients are estimated as C0 minus 0.25 and C1 0.55. The value of the third coefficient C2 would be. So it is a direct question because we know that the sum of coefficients C0 plus C1 plus C2 is equal to 1, which implies C0 minus 0.25 plus C1 0.55 plus C2 will be 1. So from here C2 will be equal to 1 minus 0.55, that is 0.45, plus 0.25, that is 0.7. So 0.7 will be the answer. Next question is, a column of height h with a rectangular cross section of size a cross 2a has a buckling load of P. If the cross section is changed to 0.5a into 3a and its height changed to 1.5 h, the buckling load of the redesigned column will be. Now we know that the load capacity of column is given by P equal to pi square EI mean by L square. So there are two cases. So for the first case, P1 will be equal to pi square E1 and I minimum will be equal to, the dimensions are a into 2a. So it will be equal to BD cube by 12. So B2a into DA cube by 12 divided by length of the column. Let the length of column, it is given to us, length is h, so h square. So this is pi square into E into 2a by 12. So pi square into E into a to the power 5, a to the power 4 by 6h square. Now in the second case, P2 will be equal to pi square E into I minimum here will be 3a into 0.5a cube by 12 whole divided by h is 1.5h, so 1.5h square. So this is equal to pi square E into a to the power 4 by h square into 3 into 0.5 cube, that is 0.125, divided by 12 into 1.5 square, that is 2.25. So this is equal to pi square E a to the power 4 by h square into 3 into 0.125 by 2 into 2.5. 1 by 6 into 12. So this is equal to pi square E a to the power 4 by 6h square into 1 by 12. So if this is P, then this is also P, and P2 will be equal to P by 12. So the correct answer would be A option. The next question is Bernoulli's equation is applicable for. Now we know that Bernoulli's equation is applicable for incompressible flow and also where energy losses are 0. So energy losses will be 0 when the flow is viscous free. So inviscid and incompressible. So correct answer would be C option. The next question is the frequency distribution of compressive strength of 20 concrete cube specimen is given in the table. If mu is the mean strength of the specimen and sigma is the standard deviation, the number of specimen out of 20 with compressive strength less than mu minus 3 sigma is. Now mu is the mean strength, so mean strength will be equal to the average of all these values. So there are total 20 values. So this 4 plus 2 plus 5 plus 5 plus 4 is total 20 specimen. So for 4 specimen the value is 23. For another 2 specimen value 28. For 5 specimen value 22.5. For next 5 specimen value 31, and the next 4 specimen 29, and the total number of specimen are 20. So the mean strength comes out to be 26.575 MPa. Now sigma is the standard deviation, and we know it is given by summation f minus mu whole square by n minus 1. So this is under root of, again similar for 4 specimen, f is 23, mean is 26.575 whole square plus, for next 2 specimen 2 into 28 minus 26.575 square plus 5 into 22.5 minus 26.575 square. Then next 5 specimen 31 minus 26.575 square plus next 4 specimen 29 minus 26.575 square whole divided by 20 minus 1, that is 19. So this comes out to be 3.697 MPa. So therefore the compressive strength less than mu minus 3 sigma. So this f will be, let f dash will be equal to mu 26.575 minus 3 into 3.697. So this is 15.485 MPa. Now all these values are greater than 15.485. So no specimen gives this value. Therefore the correct answer will be 0. The next question is the width of a square footing and the diameter of circular footing are equal. If both the footings are placed on the surface of a sandy soil, the ratio of the ultimate bearing capacity of circular footing to that of square footing will be. Now as per Terzaghi, the bearing capacity for square footing is given by 1.3 CNC plus QNQ plus 0.3 for square footing 0.4 gamma B and gamma. This is for square footing, and for circular footing Q equal to 1.3 CNC plus QNQ plus 0.3 gamma B and gamma. Now it is given to us the soil is sandy, so C will be 0, and they are resting on the surface, so Q will also be 0. And it is also given to us the diameter of circular footing and width of square footing are same, so this B and this B is same. So for square footing it is 0.4 gamma B and gamma, and for circular footing 0.3 gamma B and gamma. And we have to determine the ratio of bearing capacity of circular to square. So for circular to square it will be 0.3 by 0.4, that is 3 by 4. So the correct answer would be C option. The next question is, in a shrinkage limit test, the volume and mass of a dry soil pat are found to be 50 cm³ and 88 gram respectively. The specific gravity of the soil solids is 2.71 and the density of water is 1 gram per cc. The shrinkage limit in percent up to 2 decimal place is. Now we know that at shrinkage limit, that is Ws, the volume will be same as in the dry condition. So for 0 water content and for Ws water content, volume will be same, and it implies that void ratio will also be same. Now since volume and mass of dry soil are given to us, so we can directly calculate dry density, that is mass of sample by volume of sample which implies mass is 88 gram and volume is 50 cm³, that is 50 cc. Now we know that gamma D is given by G by 1 plus E into gamma W. So this is equal to 88 by 50 gram per cc. Now G is given to us 2.71 by 1 plus E into gamma W is 1 gram per cc. This is equal to 88 by 50. So from here we can calculate E will be equal to 2.71 into 50 divided by 88 minus 1. So it comes out to be 0.539. Now since the void ratio at this condition, that is dry condition, will be same in the shrinkage limit condition, we can write ES equal to GW, and at shrinkage condition soil will be completely saturated, so S will be equal to 1. E we have calculated 0.539, G given to us 2.71, and we have to determine the shrinkage limit, so it will be WS. So Ws will be equal to 0.539 by 2.71. So it comes out to be 0.199. In percentage it is 0.199178. So in percentage it will be 99.178. So up to 2 decimal 99.92. So this will be the correct answer. The next question is, a core cutter of 130 mm height has inner and outer diameter of 100 mm and 106 mm respectively. The area ratio of the core cutter is. Now area ratio of core cutter is given by outer area minus inner area by inner area. So this is equal to pi by 4 diameter of outer area minus pi by 4 diameter of inner area whole square by pi by 4 diameter of inner area square. So this is equal to pi by 4 pi by 4 pi by 4 will get cancelled out. Outer diameter 106 square minus inner diameter 100 square by inner diameter 100 square. So this is 106 square minus 100 square divided by 100 square 0.1236, and in terms of percentage 12.36. So this will be the correct answer. The next question is, two rectangular under reinforced concrete beam sections X and Y are similar in all aspects except that the longitudinal compression reinforcement in section Y is 10% more. Which one of the following is the correct statement? And we have to comment about flexure strength and ductility. Now first of all we should note that both sections are under reinforced. It implies that the failure will occur due to crushing of concrete, and the crushing will occur at the strain value of 0.035. Now we can always draw strain profile at failure. Now since we have concluded that both sections are under reinforced, so at the failure the strain will be 0.035 in both cases, first and second case. But the difference will be that since in this second case, that is Y section, there is more compression steel, it implies that the strain at this fiber, that is 0.035, will occur after much more strain in the tension state. So suppose this strain be E1, this strain be E2, then E2 will be greater than E1, which implies that this section will get elongate much more as compared to this section at failure. So that is section Y is more ductile. Now since there is more percentage steel in the compression fiber in this section Y, therefore the flexure strength will also be more, and hence both flexure strength and ductility are more for section Y. So the correct answer will be, the statements are given in reverse direction. So section X will have less flexure strength and less ductility. Therefore the correct answer would be A option. The next question is, a well-designed signalized intersection is one in which crossing conflicts are increased, total delay is minimized, cycle time is equal to sum of red and green time, cycle time is equal to sum of red and yellow time. So it is a direct question. We know that a well-designed signal has minimum delay time. So the correct answer would be B option. The next question is, in a flow field is given by U equal to y square, V equal to minus xy and W equal to 0. The value of Z component of angular velocity in radian per unit time up to 2 decimal place at the point 0, minus 1, 1 is. So we know that the angular velocity along Z direction, that is Z component, is given by omega Z equal to half. Since it is Z, we will move in circular direction. So Z, then X, then Y. So it will be del X, it will be del Y, and here it is X, then here it will be V. and if it is here y, then here it will be x, that is u component. So del v by del x minus del u by del y. So putting the value of partial derivative of v with respect to x will be minus y minus partial derivative of u, that is y square, with respect to y will be 2y. So it is minus 3 by 2y. X this, y this, z this. So y is minus 1. So minus 3 by 2 into minus 1, it is 1.5. So the correct answer would be 1.5. The next question is, a cylinder of radius 250 mm and weight W equal to 10 kilonewton is rolled up on an obstacle of height 50 mm by applying a horizontal force P at its center as shown in the figure. All interfaces are assumed frictionless. The minimum value of P is. So it is a question from engineering mechanics. Now first we should draw FBD. On this cylinder, total 4 forces are acting. 1 the weight by gravity, 1 the applied, second the applied force P, third normal force N from the bottom, and fourth this reaction along the radial direction R. Now the minimum value of P is required. Now just as P becomes sufficient for it to get rolled up on the obstacle, at that point the contact between the cylinder and this surface will no longer there. Hence at that time the normal force will become 0, and in this case we can say that the value of R will balance both P and W. So let us again draw this cylinder. So at the critical condition we can say that normal force will become 0 and only these 3 forces will remain. Now let this angle be theta. Since it is given to us radius is 250 mm, so this is 250. So this also will be 250, and since this is 50 mm, this distance will be 250 minus 50, that is 200. So in this triangle, this side, that is base, is 250. So that is whole this side is 250. Now total 4 forces are acting on this cylinder. 1 the weight W, second the applied force P, third normal force N from the bottom, and fourth is the reaction at this point along radial direction. Now at the critical condition, that is when this cylinder get rolled up to the obstacle and comes at this surface, at that condition the contact between the cylinder and the bottom surface will no longer there, and hence at that point the value of normal force will become 0. So to determine the minimum value of P, we will take the free body diagram of this cylinder considering only 3 forces P, W and R. Now since radius is given to us, so this total distance from here to here is 250, and since this distance is 50 mm, therefore this distance will be 200. Now since it is radius, so this distance will be 250. So we get a triangle with hypotenuse 250 and height 200, and let's say base B. Let this theta be, this angle be theta. Now At the critical condition, since normal force is not there, so this reaction force will balance both P and W. Since this is theta, this will also be theta. So R sin theta will be the vertical component. It will balance weight, and R cos theta will be the horizontal component, and it will balance P. So from here, dividing, we get tan theta equal to W by P, which implies P equal to W by tan theta. W is given to us, and tan theta we can calculate from this triangle. Tan theta is perpendicular by base. Perpendicular is 200 and base will be hypotenuse square minus base is perpendicular square under root. So this P will be equal to W, that is tan divided by tan theta perpendicular 200 divided by base under root of 250 square minus 200 square. So it comes out to be 7.5 kilonewton. So correct answer would be D option. The next question is, at a construction site, a contractor plans to make an excavation as shown in figure. This is the proposed excavation. The water level in the adjacent river is at an elevation of plus 20 meter. This level. Unit weight of water is 10 kilonewton per meter cube. The factor of safety up to 2 decimal places against sand boring for the proposed excavation is. Now the boiling condition will occur when the weight of soil at this point get balanced by the uplift pressure due to this much water head. So to determine the factor of safety, we will calculate the vertical stress due to this much soil. This will be equal to vertical stress sigma V 20, that is unit weight, into depth of soil. Depth of soil is 10 meter. So this is 200 kilonewton per meter square. And the uplift pressure will be equal to unit weight of water, that is 10 kilonewton per meter cube, into depth of water. This elevation is plus 20, so plus 20 minus 0, that is 20. So it is also equal to 200 kilonewton per meter square. So the factor of safety is sigma V by Pu. It is 200 by 200, so it comes out to be 1. So the correct answer would be 1. The next question is, the void ratio of a soil is 0.55 at an effective normal stress of 140 kPa. The compression index of the soil is 0.25. In order to reduce the void ratio to 0.4, an increase in the magnitude of effective normal stress should be. Now as per the definition, compression index is equal to Cc, that is Cc equal to delta E by log of sigma 1 by sigma 2. So which implies in our case sigma 1, that is, so we should write sigma F by sigma. So sigma F will be equal to initial stress plus change in stress by initial stress. This will be equal to delta E by Cc. So putting the values, log of initial stress is 140. We have to determine the increase in stress. So delta sigma by initial stress 140. This is equal to delta E. So void ratio changes from 0.55 to 0.4. So this is 0.55 minus 0.4 by compression index is 0.25. So solving the values, 140 plus del sigma by 140 will be equal to log inverse, that is 10 to the power 0.55 minus 0.4, so 0.15 by 0.25. So from here we get delta sigma equal to 417.35. So this will be our answer. The next question is, a water sample analysis data is given to us. Calcium ion, magnesium ion and bicarbonate ion are given to us. The carbonate hardness expressed as milligram per liter of CaCO3 up to 1 decimal place for the water sample is. Now we know that carbonate hardness is equal to minimum of total hardness or alkalinity. Now total hardness is given by the concentration of multivalent cations, here Ca2 plus and Mg2 plus. So this will be equal to total hardness concentration of calcium ion is 60 milligram per liter divided by equivalent weight of calcium. So it is 40 is the atomic weight divided by valence is 2 plus concentration of magnesium ion is 30, equivalent weight will be 24.31 by 2 into equivalent weight of calcium carbonate. So atomic molecular weight of calcium carbonate is 100 and its valence is 2. So this comes out to be 273.406 milligram per liter. Now alkalinity is given by concentration of bicarbonate ion. So concentration is 400, equivalent weight will be 61 by 1 since its valency is 1 into equivalent weight of carbonate calcium carbonate, that is 100 by 2. So it comes out to be 327.868 milligram per liter. So the lesser value of these two is 273.406. So the correct answer up to 1 decimal place is 273.4. The next question is, the dimensions of a symmetrical welded eye section are shown in the figure. The plastic section modulus about the weaker axis in centimeter cube up to 1 decimal place is. Now in this case, this is the weaker axis because moment of inertia about this axis will be less. Now plastic section modulus is given by Zp equal to A by 2 y1 bar plus y2 bar. Now since this is a symmetrical section, y1 bar, that is centroid of left area, will be equal to y2 bar, that is centroid of right area. So we can write it as A by 2 into 2 into y bar. So it is nothing but simply A into y bar. So we have to calculate two things: total cross sectional area of eye section and the centroid of this half section. Now total area will be equal to, there are two flanges, so 2 into 140 into 9 plus web, the total depth is 200 minus 2 into 9 into the thickness is 6.1. So the cross section area is, area is 3630.3 mm square. Now y bar will be equal to the centroid of this shaded area. So we can determine it in two parts. The centroid of this flange and this flange portion will be area 2 into 70 into 9, and centroid will be from this axis at half of 70, that is 35, plus this web portion, its height is 200 minus 2 into 9 into its thickness is 6.1 by 2 and its centered will lie at this point, which will be 6.1 by 4 whole divided by the area of section. So area of section is nothing but total area by 2. So this comes out to be ZP will be equal to A into Y. So A is 3630.3 into Y bar is this value. So it is 2 into 70 into 9 into 35 plus 182 into 6.1 square by 8. So this is 44946.5 divided by 3630.3 by 2. So this is equal to 89893.055 mm cube, and in centimeter cube this will be equal to 89.89 centimeter cube, neglecting 3 decimal places. So the correct answer will be 89.89. The next question is, the figure shows a simply supported beam PQ of uniform flexure rigidity EI carrying two moments M and 2M. The slope at P will be. Now to determine this, we can use conjugate beam method. So first of all, we should solve for the bending moment diagram of this beam. Since the two ends are hinged, moment at this point will be 0, moment at this point will be 0. Now moment will linearly vary up to this point, and since it is clockwise movement, it will get jumped and it will reach this value, that is 0. Again it will linearly vary, and since here moment is 2m, it will jump by 2m. So from minus m it will go up to plus m, and again it will go downwards 0 value. So this is minus m, this is minus m, this is plus m, here 0 and 0. So this is our moment diagram, that is BMD. Now to determine the slope at P, we will apply this bending moment on the conjugate beam. So in this figure itself, I am drawing the conjugate beam. So the conjugate beam will be here hinge support and also here hinge support, and the loading diagram will be here M by EI and by EI. Now from the conjugate beam concept, we know that slope at any point is equal to shear force at the corresponding point in conjugate beam. So we have to determine the shear force, that is the support reaction at this point. So to determine this R1, we can take moment about this point. So summation of moment, this will be equal to moment due to this force, which will be equal to R1 into L by 3 plus L by 3 plus L by 3 into L, minus moment due to all these loading. The loading will be like this. So starting from this load, total load will be equal to half of base, that is half of L by 3 into M by EI, and the lever arm will be L by 3 plus L by 3 plus 1 by 3 into L by 3. So this will be equal to half of L by 3 into m by ei into L by 3 plus L by 3 plus L by 9. So it is 2L by 3 plus L by 9 minus moment due to this loading. So again the force will be same, half of L by 3 into m by ei, but lever arm will get changed. This is L by 3 plus this distance will be L by 9. Finally this force is acting in upward direction, so we will get plus. Force will be same, half of L by 3 into m by ei, and lever arm will be this much distance. It will be 2 by 3 of L by 3. So it will be 2L by 9. And this whole moment will be equal to 0. So from solving this, R1 into L minus this minus this minus this plus this. So from here we get R1 into L equal to, taking values on RHS and taking ML by 6 EI common, we will get 2L by 3 plus L by 9 plus L by 3 plus L by 9 minus 2L by 9. So solving this, we get R1 into L equal to ML by 6 EI, and this whole value comes out to be L only. So L and L will get cancelled out. R1 will be equal to M by ML by 6 EI, and therefore the slope will be same, that is C option. The next question is, a conventional drain triaxial compression test was conducted on a normally consolidated clay sample under an effective confining pressure of 200 kPa. The deviator stress at failure was found to be 400 kPa. An identical specimen of the same clay sample is isotropically consolidated to a confining pressure of 200 kPa and subjected to standard undrained triaxial compression test. If the deviator stress at failure is 150 kPa, the pore pressure developed is. Now first of all we know that the relation between principal stresses is given by sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Now since it is given to us the soil is clay, the value of C has some finite value, but conceptually we must note that here in the first test the sample is consolidated, and again the identical sample is used in second test. So for consolidated clay sample, C is always 0. So because whether it is sand or it is clay, the failure envelope will start only from origin when the soil is consolidated, and hence we can neglect this term. So sigma 1 will be equal to sigma 3 tan square 45 plus 5 by 2. Now for the first case, it is a drain test. So in a drain test, sigma 1 will be equal to the total stress, so it will be confining stress plus deviator stress, and sigma 3 will be the confining stress into tan square 45 plus 5 by 2. Now confining stress is given to us 200, deviator stress is given to us 400, So 200 into 10 square 45 plus 5 by 2. So from here we can calculate phi will be equal to 600 by 200, that is 300, that is 3, and under root of 3, that is root 3. So tan of 45 plus 5 by 2 is tan inverse of root 3. So tan inverse of root 3 is 60 degree. So we can write 45 plus 5 by 2 equal to tan inverse of root 3, that is 60 degree. So from here we get phi equal to 30 degree. Now in the second case, it is an undrained test, consolidate sample and then undrained test. So it is CU test, and for this case we should write this equation including the effect of pore water pressure. So here sigma C plus del sigma D minus U equal to sigma C minus U into 10 square 45 plus 5 by 2. The confining stress is same 200, deviator stress is 150 minus U equal to sigma C 200 minus U into this value will be same, that is 30 by 2. So it comes out to be 3. So from here value of U will be equal to 125 kPa. So 125 will be our answer. The next question is, given the following data, design life n equal to 15 years, lean distribution factor D equal to 0.75, annual rate of growth of commercial vehicle R equal to 6%, vehicle damage factor F equal to 4, and initial traffic in the year of completion of construction equal to 3000 commercial vehicles per day. As per IRC, the design traffic in terms of cumulative number of standard axles in million standard axles up to 2 decimal places is. So it is a direct formula based question. The design traffic in terms of million standard axle is given by n equal to 365 into A into 1 plus R by 100 to the power n minus 1 into vehicle damage factor F into lane distribution factor D divided by R by 100. So this comes out to 365 into initial traffic is A, that is 3000, 1 plus rate of growth is 6%, so 6 by 100 into, and the year of completion and the design life is 15 years. So it is 15 minus 1, F is 4, D is 0.75 whole divided by 6 by 100. So it comes out to be 76.45 million standard axle. So the correct answer will be 76.45. The next question is, a plate in equilibrium is subjected to uniform stresses along its edges with magnitude sigma xx equal to 30 MPa, sigma yy equal to 50 MPa as shown in the figure. The Young's modulus of material is 2 into 10 to the power 11 Newton per meter square and Poisson ratio 0.3. If sigma z is negligible and assumed to be 0, then the strain EZZ is. Now from the stress theory we know that strain along ZZ direction is given by sigma ZZ by E minus mu into sigma XX by E minus mu into sigma YY by E. So this is equal to sigma zz is assumed to be 0, so we can neglect this term, and mu and e are common, so minus of mu by e sigma xx plus sigma yy. So this is equal to minus Poisson ratio is 0.3 by e given to us 2 into 10 to the power 11 Newton per meter square. Sigma xx is 30 MPa and both are in tensile direction, so both are positive. So it is 30 into 10 to the power 6 Newton per meter square plus 50 into 10 to the power 6 Newton per meter square. So it comes out to be minus 0.3 by 2 into 10 to the power 11 into 50 plus 30, 80 into 10 to the power 6. So this is equal to minus 120 10 to the power minus 6. So the correct answer would be B option.